Good morning, everybody. We're going to continue looking at some financial mathematics today. We're going to look at some depreciation and a couple of more complicated problems here using a calculator. So again, if you haven't, I would make sure you have some sort of graphing calculator. I use the TI Graphing Calc 83 right there. You know what? I think I'm going to go and try to get sponsored by them. So I guess smash that like button, subscribe to my channel so I can get some clout for this Graphing Calc 83 sponsorship that's coming my way. So for today, we're going to talk a little bit about depreciation. So depreciation is when things lose value over time. So some things that lose value over time, we've got cars, we've got computers, furniture, boats. So basically anything that has wear and tear, the technology becomes old, they make better versions of it. Typically those things are going to lose value over time. And so mathematically, depreciation is similar to compound interest, except your value is going to be decreasing here. It's going to be there's going to be some exponential decay. So when we're talking about depreciation, we're talking the same type of formula that we were looking at, except instead of adding that rate to our 1, which represents 100%, we are now going to be subtracting it. So again, we are in the red book here, so I'm going to start by looking at example 17, which is page 120. So here we've got a dishwasher which was purchased for 2,400 pounds, and this dishwasher, I guess they ran a study on it, and it depreciates by 15% each year. And so we want to know, okay, if this thing's depreciating by 15% each year, what's its value going to be after 6 years? So we're trying to find out what U sub 6 is here. So its initial value is 2,400. And so if it's depreciating by 15% each year, that means, that's going to be 1 minus 0.15. That means it's going to maintain 0.85 or 85% of its value each year, which makes sense. It loses 15%. It's going to maintain 85% of its value. Now, it's going to experience that drop. The exponent here is going to be 6. It matches up there because it's going to experience that drop there 6 times. So then let's see here. 2,400 times 0.85 to the 6th power. So in 6 years, that same dishwasher, even if it's still working well, we're going to round to two sig figs here because we're working with money. So 905 pounds and 16, I guess, pence. Again, I haven't looked up that. I need to look it up. I just keep forgetting to. And so then one of the things when you're looking at depreciation is it matters in reference to the original item, how much you've lost. So let's see here. So we want to figure out by how much did this thing depreciate by. So to do that, all we're going to do is we're going to take the original here, which it was 2,400 pounds. We're going to subtract 905.16. And that's going to give me 1,494 pounds and 84 pence, I think. So that's just a quick look at depreciation. Now, the main thing that we're going to look at today, we're going to look at some more complicated financial problems that we're going to have to use actually an app on the calculator for the next few days. So what we're going to do is we're going to use what's called the TVM solver, which just stands for the time value of money solver. So when the designers of these calculators made these calculators, they made them very intuitive. So if you're looking for an app, you want to go and hit that big app button there. And you're looking and you're like, oh, okay, what have we been studying? Was it Polysmall? Was it geometry? Was it chemistry? Was it finance? So if you've been paying attention, we are studying finance right now. And TVM solver right there is the first one. So let's I guess I'll put zeros in. I'll zero this out just for our example's sake. So let's talk a little bit about what each of these things mean, and then we can start using this to help us solve some problems. So this N right here is referring to the number of periods in total, whether it's payment periods or compounding periods. We'll look at what that means here in a bit. The I percentage just stands for the interest rate, and they just want that as whatever the interest rate is. No converting that. PV stands for the present value or the principal. The payment, if we're dealing with a problem that involves a payment, that's just how much money you're paying off per month. The FV here is the future value, or the U sub N, if you want to think about it that way. And then P/Y is the payments per year, C/Y is the compounding periods per year, and those will usually be the same number. So we're going to use this app to help us explore some problems here and try to get a better intuition for what's going on. So first one that we're going to look at is we're going to look at example 18 on page 122. So we've got Sally here, and Sally is investing $15,000, in an account that's going to pay 4.25% interest compounded monthly. So we want to know, okay, how much is her investment going to be worth after 5 years? So when we're doing this, the first thing we need to say is, okay, N was the total number of periods. So we've got, it's compounding monthly for 5 years. So think to yourself real quick, if it's compounding monthly for 5 years, how many times is that going to compound? How many periods are there? So that's just going to be 60, because that's what 5 years times compounding monthly is going to give you. The interest rate here is going to be 4.25. The present value, so this is the one that's a little bit tricky. This present value here is going to be negative 15,000, because when you invest something, that's money leaving your account. It is invested somewhere, but that is not money that you can always readily access depending on what type of account it is. The payment, there's no mention of payments here, so we're going to put a 0 there for the payment. The future value, we are not sure what that is, so we're going to put a question mark there and come back to it. Since it's being compounded monthly, both of these things here are going to be 12. So then what I'm going to do is go in to this app here, the TVM solver. Again, that's under apps. So the number of periods is 60. The interest rate's 4.25. The present value is negative 15,000. The payment is 0. We'll get to the future value here in a second. We got 12 and we've got 12. So if you've got everything else in, it may work a little differently if you have an actual calculator. We can figure that out. Talk to me in Zoom and we can figure it out if you're using a physical TI. But whatever you're trying to find, you just bring that cursor to it, and if all of your other information is correct, you can hit solve and it will tell you what that amount should be if all of the other variables are worked out. So the final value here is going to be $18,544.52, and that's a problem that we could solve by hand using the information that we learned last class. But so you can check that by hand if you want to do so, but there's going to be some problems where it's a little bit more complicated, that we don't necessarily have the tools at this stage in your math career to solve those yet. So so everything that we're doing today is going to be using the TVM solver. So if you have any questions on that, please ask. So then I'm going to write this stuff out, and then we can look at the next one. So the payment, we've got the future value, we've got the payments per year, and the compounds per year. So let's get after it. IB Juniors. So we've got Helena here is investing money in a term deposit paying 5.2% compounded quarterly. How much does she need to deposit now? So does she need to deposit now in order to collect $5,000 at the end of her 3 years there? At the end of her 3 years there. So when we're looking here, we're saying, okay, well, we need to fill in some information. Excuse me. We need to fill in some information concerning this account. So what we've got here, so for the compounding periods here, it's compounded quarterly, so 4 times a year for 3 years. So 3 times 4. So we're just going to use 12 as the number there. The interest rate is 5.2%. That's what we're drawing. What we don't know is what the present value is. We want to know how much money do we have to deposit to end up with $5,000. There's no mention of payments yet, so it was 0. We want the future value to be $5,000, and we know payments per year and compounds per year are both 4. So with that, I'm going to substitute that in here to this TVM solver, and this is one that again would take us a little bit longer to solve, and we might have the tools in our math toolbox at this point to solve it, but we're going to get to some harder ones that we can't necessarily. So I'm going to go and hit solve there. So we've got negative $4,282, and that's going to round up to 10 cents. So that is the amount that we would have to invest here in order for that to be $5,000 in 3 years. And some of you may be looking at that and being like, well, Mr. Price, that's not a ton of money. What is the point of investing if I'm only going to make $700? The big thing here is that you need to look at how much money you've made in comparison, percentage-wise, to the original amount. So, like, if you do 5,000 divided by 4282.10. Your money is increased, so it's 116% of its original worth. So your money is increased 16%. And the way that those percentages work, if the more money you have invested, the bigger of a number 16% of your money is going to be. You always hear of the rich get richer, because 16% of $1 million is significantly more than 16% of $5,000. So this the principles or the increases in money here, when it's smaller amounts, may not look as substantial, but it's just the amount of money that's deposited. The more money you deposit, the more money you will make off of an investment. So then let's look at a couple more to finish today off. So I'm going to start by writing this stuff here. It's going to make my life easier. I apologize for not having written this previously, but it'd be like that sometimes. Payments per year, compounds per year, and now we can read this problem. So, for how long must Magnus invest $4,000 at 6.45%, compounded half yearly, for it to amount to $10,000? So this is another worthy finance question. How long am I going to have to wait until I can finally get my money? Well, what's it going to take here? So, if we're talking in terms of number of years, we don't explicitly have one for that, but we do have one for number of periods. So that's going to be what we're trying to find here. So let's see here. The interest rate percentage is 6.45. The present value is negative 4,000. That's the amount that's leaving us. There's not a payment here yet. The future value, we want this to be 10,000, or I guess 10 stacks, as the youth would say. And then the payments per year and the compounds per year here are going to be 2, because it's half yearly. So I'm going to fire up the old trusty TVM solver again. Apps, we're learning about finance. We're doing the TVM solver. 6.45. What am I doing? 6.45. Negative 4,000. Mr. Price can't type right now. 10,000. And we got 2 and 2. And we are trying to find the number of periods here. So I'm going to solve that. So that's going to be 28.8. I'm going to round that up to 29. Because if it is compounding half yearly, you're not going to get that. You're not going to get the compounding until the next half. So that wouldn't occur until the 29th. Now the thing is, what we have to understand here, is that this is half year periods. That's what N stands for, the periods here. So we want to know the amount of time. So think to yourself real quick, how much is 29 half years? So we're going to divide 29 by 2, which is approximately 14.5 years. And again, it is important to think about this in terms of the percentage that your money is increasing here. So you may just say, okay, Mr. Price, 4,000 to 10,000, that's just $6,000, man. Investing's for the birds. But from 4,000 to 10,000, your money is more than doubling. I think it's increasing by 250%. So like, if you added a 0 to this 40,000 and you added a 0 to this 100,000, it would still take the same amount of time. Or if you added a 0 to this again and made this 400,000, you added a 0 to this to make it 1,000,000, it would still take the same amount of time. That's the beauty of this compound interest. Now, in the book, obviously, it has the examples with smaller numbers to make it more accessible to you all, because you're like, oh, $400,000, who's got that, Mr. Price? Who's investing that kind of money? This stuff occurs over time, though. It doesn't all happen at once. For some people, it does. For some people, it does not. So, again, I'm going to write this out, and then we can look at this last example for today. Payments per year, compounds per year. So in this last example here, we've got Aman depositing $5,000 in an account that compounds interest monthly. Let's see, 2.5 years later, the account has a balance of $6,000, and we want to know what is the interest that's getting paid here. What is the interest that's getting paid? So let's fill in what we know. They deposited $5,000. So we don't know the interest rate. I'm just going to put a question mark there. It's compounded monthly. So 12 for 2.5 years. So half of 12 is 6 times 24. That's going to be 30 periods. The payment here is still 0. We're not really dealing with things that require payments today. We will here very soon. The future value is 6,000. And then the payments per year, the compounds per year, that is monthly. That's going to be 12. And so we want to know, okay, what is the interest rate that we're getting here For whatever reason, it's difficult to find. So let me go back to this. We're going to that TVM solver. No, not to X, to TVM solver. I'm fat fingering all this stuff. 30. We can, I'll punch in 0. We don't really need that though. Negative 5,000, 0, 6,000, 12, and 12. And we want to solve for the interest rate there. So let's hit solve. So that interest rate there is 7. We'll call it 32%. 7.32%. And so that, in a nutshell, is kind of a introduction to depreciation, as well as some of the mathematics that we're going to explore a little bit more with a calculator. So again, if you all have any questions, generally about any concepts that we're going over, if you have a money question in general or a calculator question in general, please let me know. Again, I do think that this is some very important stuff that we learn. I do like to answer any questions that may occur. I can't promise I'll have the answers, but I can promise that I will try my best to find it or to ask someone who knows better than I. So I hope you all have a good rest of your day, and if you need anything, please let me know.